We'll go ahead and begin our lesson today with a review of what we did in our last lesson. We had scientific and standard notation. Remember that standard notation is any number, for example 327, the number 4, and on from there. Scientific notation is any number that is written as a number times 10 to a specific power, let's say the third power. Remember that this number has to be between 1 and 10. It cannot equal 10. So it has to be between 1 and 10. It can be 1, but cannot be the number 10. Another thing that we talked about was how to multiply a number or divide a number when it's already in scientific notation. For example, if we took the number 1.4 times 10 to the 7th and we wanted to divide that by 2, you only need to pay attention to this number before, right here. So you would take 1.4, divide it by 2, which would give you 0.7. You keep times 10 to the 7th. However, because this number is not between 1 and 10, you need to change it to be between 1 and 10, so move this decimal point over 1 time, so you would have 7.0 times 10. Now remember, a positive exponent means it moves to the right. When we changed this into scientific notation, we already moved it 1 time to the right, which means we have only 6 more to go. So this would be your number in scientific notation. Okay, before we get too far into what we're actually going to do today, here's a list of all different types of jobs and professions, careers that you can get into that use exponents. So if any of these are of any interest to you, they do use exponents on a rather regular basis. Now these aren't the only ones who use exponents, but they do use them and use them frequently. So you may want to keep all of this in mind if any of these are interesting. Before we get into this lesson, we also wanted to talk about what exactly it means to raise a base to an exponent. Now remember, when a while back we actually talked about an example like this with 3 to the 2nd. Now this number 3 right here, that would be considered the base. Okay, and then the number up top, of course, is, that would be our exponent. Now if you see the word power, that means the whole thing. Okay, so all of that together is considered the power, while just the 3 is the base and just the 2 is the exponent. Okay, so when we're talking about exponents, what they actually mean, if we see something that is 2 to the 4th power, what that really means is we take the number 2 and we multiply it by itself 4 times. You have to be careful, and I'll even write this out. 2 to the 4th is not 2 times 4. Those are two completely different things. Okay, so this means 2 times 2 times 2 times 2, which in the end you get 4. Multiply by 2 again, and that becomes 8, and then by 2 again, and you get 16. Okay, so just make sure that you're using the powers correctly. Now if you have a negative number being raised to an exponent like this, since this negative 3 is not in parentheses, what this is really saying, it's negative 1 times 3 to the 3rd. So really we have negative 1, and then we have the 3 separate times. If I were to do this, negative 3 to the 3rd power, that would mean negative 3 times negative 3 times negative 3. So make sure you keep a close eye on this and make sure that you look for the parentheses. If there are no parentheses around the number, then you're only taking the number itself, not the negative, and raising it to the third power. Now as we go on, y to the third would be y times y times y, n squared, n times n. Now we have a negative exponent in this example. Remember to make it positive, put it over 1, do the reciprocal, so it becomes 1 over k to the 5th power, which is really 1 over, and then we have k times k times k times k times k. So we've got that 5 times. Okay, so now that we've talked about what exactly they mean, let's go ahead and get into this chapter. So we're multiplying powers with the same base. Okay, now remember, the base was the number that was raised to the exponent. So in this case, the 3 is the base. A rule that you always want to follow when you are multiplying numbers with the same base, but different exponents, you add the exponents. So, for example, the base here is 3. The base here is also 3, so since they have the same base, we take the 2 and the 4, which are the exponents, add them together to get 3 to the 6th power. Now after that, you would also simplify 3 to the 6th power. Remember that it means 3 times 3 6 times, not 3 times 6. Be careful. And this actually comes out to be 729. Here's a second example. We have 5 to the negative 4th power and 5 to the negative 3rd power. When you add those together, remember they're both negative, so you end up with a negative 7. When you have a negative exponent, remember to do the reciprocal, move it down to the bottom, and you end up with 5 to the 7th on the bottom, and once you figure that out, it's 78,125. Again, be careful, it is not 5 times 7, it is 5 to the 7th power. Let's go ahead and look at some of these. Now if we look at this example, the base here is 3, the base here is 3. So what we can do is keep the base as it is. Those are not multiplied. Okay, so be really careful with that. A lot of people want to make this become 9 to a certain power, but that is not right. So no, we don't do that. Okay, so you keep the base. I should put the red X through that. All right, keep the base as it is, but we will add our exponents. So we have 3, and then we're adding to that a negative 4. So really we have 3 to the negative 1. Remember to always simplify, no negative exponents. Okay, so what we do is put it over 1, change it, make it the reciprocal, 1 over 3. Remember to not write the exponent if it is 1. So here is our final simplified version of our original problem. Now moving on to the second example, we have negative 5 as a base and negative 5 here as a base. So again, this stays as a negative 5. This does not become 25 to a certain power. So be careful. That's a big no. So be careful with that. Do not multiply them. Keep it as the 5. Okay, so what we do is take our exponents, add them to plus 3, so we get negative 5 raised to the 5th power. There is no parentheses here. All right, so what that means is we raise the 5 to the 5th power and then tag on the negative. So really this is negative 1 times 5 to the 5th. When you raise 5 to the 5th, you get 3,125 and multiply it by the negative 1. So your final answer is right there, negative 3,125. Moving on, now I'll introduce you to the variables. If you pull variables into this situation and you want to simplify this as much as possible, even though these are our only multiplication signs that we have in this problem, everything is being multiplied. So really this is 5 times x to the 4th times x to the 9th times 3 times x. If we use the commutative property, so if we use our commutative property of multiplication, we can rewrite this whole phrase up here and actually move our numbers together. So we have 5 times 3, and then move the variables so they're next to each other. X to the 4th times x to the 9th times x. From here, we're going to go ahead and use our associative property. So associative property of multiplication. Okay, and we're going to group together our numbers, and we're also going to group together our variables because they have the same base. Now, even though 5 and 3 are not the same base, we're not adding the exponents, we're just multiplying them to simplify. So what we get here is 15, and then here we have x, now we have to the 4th power, plus the 9th, plus the 1st. Remember, and this is really tricky, a lot of people forget, but remember with this one, the exponent for it is 1. It's not written here, and a lot of people tend to forget and you only use the 4 and the 9, but if there is a variable, there is an exponent every time. So once we combine everything, we end up with 15 times x to the 14th power, and there we go. There is our answer. Okay, one more with this. Now if you look, I introduced a second variable. So again, we know that we can write this, it's all multiplication. Okay, so it's all being multiplied. So I'm just going to go ahead and skip and do the commutative property right away and take 2 times 9 times 3 and then group my a's together times a squared and then tag that b squared on at the end, or I'm sorry, b to the 4th. All right, now we use the associative. Okay, and we group together what we want to group. So we take that 2 times 9, times 3, group together a times a squared, and then that b to the 4th is just by itself. It doesn't have any like terms. So when we combine this one, we end up with a total of 54. Here we get a to the 1 plus 2, and then we have b to the 4th power. Now remember, again, here, no exponent is written there, but even if there is a variable, then the exponent is there, it is the number 1. So when we simplify everything, we get 54, a to the 3rd, b to the 4th. And this would be your simplified expression that would match your beginning expression. Okay, now I'm introducing just a little bit more confusing. We have the negative exponents, but we also have a negative number here. One thing that I have noticed over the years is that people tend to make the mistake that a negative number becomes positive, so that this would be a positive number if you moved it to the bottom. Nope, not the case. The only thing that changes is the exponent. Okay, so what we're going to do is go ahead and use that commutative property again and move things. Now with all these parentheses, remember that this is all just multiplication again. So I'm going to take that 3 and put the 2 right after, put the negative 4 right after that. I'm going to go ahead and make sure that the d squared and d to the negative 5th power are next to each other, and then c. Okay, now when you go to multiply these terms, you will get a negative number, and that's fine. The negative number can stay in the numerator. It does not move if it's a negative value. So you end up with negative 24. Keep it on the top. Do not move that. Now when you combine these two, you have D, then 2 plus negative 5, and then C. What we end up with here, negative 24 stays as it is. D is now to the negative third power, and then we have C. Okay, now, this number, again, I'm reiterating this because it continues to be an issue. This number, negative numbers do not, actually I shouldn't say that, they don't, let's say change sign, that'll be shorter to write. They do not change signs by switching to denominator. Okay, so you don't change it. So we keep that negative 24. Now remember, this number right here, while it is being multiplied by this D to the negative third, the negative 3 is only attached to this variable. Okay, so when we are simplifying and we're getting rid of our positive exponents, or our negative exponents, so that we only have positive exponents, this value is the only thing that moves to the bottom, and it becomes D to the positive 3 on the bottom, and then C stays up top because it is a positive exponent of 1. And there is your simplified version. All right, and if I'm not mistaken, this is our last problem. Now let's say we're going to go ahead and use scientific notation to multiply two numbers. One thing that you will do, and the very first thing, you just take this 2 and multiply it by this 0.3. So you would end up with 0.6. Okay, now we have times 10. So now the base is 10 and 10 raised to the third, raised to the second. So we go ahead and do the 3 plus 2. So we have 0.6 times 10 to the fifth. Now when you look at this number, this is not in scientific notation because that first number is not between 1 and 10. So remember, when you move this decimal point over 1 so that it is between 1 and 10, you get 6.0 times 10. And now this 5, remember that means you're moving to the right 5 times. We've already moved it once here, which means we only have 4 more to go. Just as a quick example, because I noticed that both of the scientific notation problems I did, when we switched from this version to this one, we changed this to go down by 1. So I would like to say, just as a reference point, if you had, after you multiplied, you got 70 times 10 to the fifth. The the decimal point would be after the 0, so we would want to move it here and make it 7.0 times 10. Now with this, 5 again means you're going to the right. We went to the left, which means we have 6 times to move over to get it back to where we started from. So that would be 10 to the sixth instead of it going down like it did in this example. Okay, so you just have to think about, what is the exponent telling me to do? How do I move this? So, quick recap. When powers have the same base, add the exponents. Always add the exponents. Keep the base, all right? So keep the base. On to these examples, remember we kept 3, we did not change it to 9. We kept -5, we did not change it to 25. Further, and we got to this example. Remember that if it's a negative number, a negative coefficient, that does not change signs when you move it to the denominator. So you do not move it, so don't move it. Keep it where it is, keep it negative. The only thing that changes signs is this exponent here will become positive when you move it to the denominator.